Robert, you've mentioned professional code reviews. Can you tell us a bit more about your approach?
Sure, Andrew. It's about analyzing code, not just for bugs, but for efficiency, maintainability, and overall design.
So, is this completely objective? Could personal preferences creep in?
Well, it's best to try to be objective, but some subjective judgments are unavoidable, you know. A good review considers the context of the code.
Context. So, the author created this serial date class. Why would someone want to make their own date class when Java already has java.util, date and calendar?
Good question, Andrew. The author probably encountered a specific need that the standard libraries didn't fully address. Maybe a need for handling dates specifically without times.
That makes sense. What are some common date issues in Java code?
Formattning, timmezonehandling.
And even simple things like parsing dates from strings can get tricky. Serial date might be well suited for a specific kind of problem.
Could you highlight a possible issue with the serial date implementation?
One potential issue is how it handles leap years.
Interesting. So, how does a code reviewer strike a balance between finding fault and offering useful guidance?
It's about providing specific examples and explaining the why behind the critique. Focusing on the impact on maintainability is key.
That's valuable. Thanks, Robert. This is really helpful.
My pleasure, Andrew. We should all strive to write maintainable code.
Definitely a powerful lesson. Hey, Robert, great to have you back. So, we were talking about making code solid. This example really highlights the power of thorough testing, right?
Absolutely, Andrew. It's a classic case where tests uncover things we wouldn't have noticed otherwise.
So, what's the secret sauce to writing these amazing tests?
A combination of strategies, Andrew. First, you need good test coverage. Think about all the possible inputs and outputs of a function. Edge cases are critical.
But how do you decide what counts as an edge case?
It's often about looking for those boundaries. Values at the extreme ends of a range, or unusual combinations of values. A classic example is something like the 0, 1, and 12 of a month in a date calculation function.
I see. So, tests help us find these unexpected behaviors?
Exactly. And sometimes those surprising behaviors reveal deep-seated problems in your logic. Think about the boundary conditions.
Makes sense. And is thorough testing always the best approach?
Well, it often buys you more confidence in your code. However, it is important to weigh time and resource constraints. Sometimes, a quick and dirty solution will suffice in a simple application.
Okay, makes sense. So, how do you best deal with legacy code? And how much time should be dedicated to fixing bugs?
For legacy code, incremental improvement is key. Target obvious issues first using test-driven development to fix bugs quickly.
That's a good approach. I think we should wrap it up there for today.
Yeah, good discussion, Andrew. It's good to revisit code quality.
So, Robert, you've just outlined the benefits of this Boy Scout rule approach to coding. What are some real-world examples of when following this rule really pays off?
Absolutely. Imagine a project that's a year old, a dozen developers have worked on it, and the codebase is a tangled mess. Someone new joins the team, and fixing a simple bug takes them days, because nobody understands the code.
Wow, that sounds frustrating. So, what's the difference in code between the messy and tidy example?
Well, shrink means reducing unnecessary lines of code. For example, replacing complex conditional statements with a concise function call can streamline things.
And clarify is about making the code easier to read?
Exactly. Comments, clear variable names, and well-structured functions are key. It's about writing code that other people can easily follow, even if they didn't write it.
But isn't there a trade-off? Spending all that time cleaning up the code might slow down the initial development?
You raise a good point. But look at it like this. A well-designed structure is a good investment. A house built on a solid foundation will withstand more storms.
Makes sense. But how do we measure these improvements?
Look at test coverage and bug rates. Clean code often leads to more robust unit tests that detect errors earlier in the development cycle.
So, fewer bugs means less time troubleshooting later?
Exactly. And the increased readability reduces time spent figuring out what the code does, an enormous savings in debugging time.
So, Time to refactor and tidy up is really an investment, not a cost.
A smart investment. It leads to less rework down the road, and happier, more productive developers.
You've touched on the human side of this. Makes sense now, the Boy Scout rule.